children of the stars, growing up under the golden gaze of our nearest and most precious star, the sun. But where did this benevolent giant come from? And what will be its fate? The sun that moves through our skies appears to be the most dependable aspect of our universe. An amber disk rising without fail day after day. But the sun has a long and turbulent past. Its future too will be violent and spectacular. This is the story of our sun, from Genesis to extinction. Understanding the sun's life cycle requires time. You can't watch a tree for 5 minutes and discover how trees grow. But look to the night skies. It's a forest, stars in all stages of growth. Here are the solar seeds, shoots, saplings, and decayed wood. Together, they tell the 10 billion year life story of our sun. It's a biography that can be read by the Hubble Space Telescope. With its amazing close-ups, it pieces together our sun's story by showing us other stars during birth, growth, and death. Poised 380 miles above the Earth, Hubble views the heavens, our eye to the sky, an eye with 20/20 vision.
Looking at the stars from the ground is like looking up through the bottom of a swimming pool where everything is smeary and distorted. That's why stars twinkle at night. Once we get into space, we have an exquisite clarity. That allows us to see things that are 10 times clearer than you can ever see from the ground.
The earthbound view blurs. But in orbit, Hubble's eye zooms into the distance. And then zooms again through a peephole in our galaxy to other galaxies so distant that the journey of light takes 10 billion years. But Hubble doesn't need to see that far to relate the opening chapter in our sun's life. The space telescope turns and sees Eta Carina, a titanic superstar. The violent furnace at its core is a fantastic nuclear reactor. Being fused in this crucible of creation are the elements needed for life. But it is a star on the verge of self-destruction. The two massive clouds of dust presage the blockbuster that is to come. Eta Carina will soon end its years as a supernova. In the giant detonation, small atoms are thrust together to make larger, more exotic atoms. Only here does the cosmic touchstone create the precious metals gold and platinum. No wizard who ever waved his wand could have brewed such alchemy. Blasted out, this gas and stardust can form fabulous clouds called nebulae, here taking the shape of a crab. More debris, but here blown across the heavens by the blast from supernova, draping the sky as the Veil Nebula. In contrast is the vast Eagle Nebula, where time and stellar wind are sculpting cosmic debris into great columns. Our entire solar system would be less than a pinhead against these enormous clouds, pillars of creation seen by Hubble. Billions of years ago, ingredients like these were part of the fantastic brew that came to be our own precious solar system. On Earth, blast waves destroy all in their path. But in space, they can be waves of Genesis. Over 6 billion years ago, the blast from a supernova crashed through a cloud of dust and gas. This dying breath was the kiss of life for a new star. The dust is concentrated by ripples of galactic shock. Gravity pulls in still more material. Heat and pressure at the core become intense. A nuclear reactor fires up and jets of gas shoot out. Real starbirth seen by Hubble. Telltale jets of a tearaway infant star.
Our sun was like this, and we've seen for the first time the environments around stars that are forming. And we've seen it on the scale of our own planetary system, and we've seen what we long suspected would be there.
Jets heralded the dawn for our sun 5 billion years ago. Around it swirls a disk of gas, dust, and rock. It's a cosmic soup slowly being stirred. The gravity of the central star pulls upon this maelstrom. Heavier elements such as metals stay near the center, while the lighter elements, hydrogen and helium, escape to the outer regions. This separation will give the planets that they are forming their different characteristics. Our solar system at its birth. Reality or speculation?
The nearest place to find out is in the Orion Nebula. We think that's a region where stars are forming like our sun right now.
A stellar nursery where regions of dust and gas are collapsing, compressing, and then kindling the nuclear fire of starbirth. Hubble sees into the Orion with amazing clarity. Look closely and see a star. Although burning bright, it's almost obscured by the disk of dust that swirls around it.
Now with the Hubble pictures, you can see that there are disks there which are about the size of our own solar system and might indeed form solar systems like ours.
Over 4.5 billion years ago, around our own sun, spun a frisbee of rocks and dust, rotating in the same direction, waltzing to the same tune. But the dance was not at all serene. Fragments collided and coalesced. Out of the debris slowly grew the sun's family. With so much material flying around, it wasn't always easy to survive. Young planets were struck. Some were annihilated, others reformed. As embryo planets grew, their gravity increased, attracting even more material. A few large planets formed, some big enough to have their own entourage of debris. This complex swirl of activity eventually settled down, and around the central star promenaded a few new planets. Their gravity drew in the remaining debris, and they continued to add mass. Finally, it was possible to make out just a handful of planets circling a star. But the star was having growing pains. From deep within, the nuclear inferno raged, forcing the young sun to expand. But gravity pulled the star back in. It was like a giant tug-of-war. After 1 billion years, the sun reached equilibrium. And slung in the harness of its gravity are the young planets. Our solar system had been born. But are we living in a unique system? Possibly not. Perhaps in the corner of some galaxy there exists the exotic children of some other star. Hubble has started to look. It sees another star with a disk of swirling dust called Beta Pictoris.
The discovery we made around Beta Pictoris is that it's surrounded by a disk of material. And the exciting thing about this is the configuration of the material that we saw, the shape of it, is actually in a flattened disk, as if it were a phonograph record with a star at the very center. But there's a clearing of material, and that clearing is about the size of our own solar system. And the indication there may be that the clearing is caused by the formation of planets.
So far, no planets have been detected around Beta Pictoris.
Planets are extremely hard to see directly. If you can imagine trying to read the inscription on a flashbulb as it goes off in your face, a planet is about 1 billion times fainter than the parent star, and it's right next to it.
The Lick telescope also hunts for planets, but it does so by looking at stars.
We can't see the planets directly orbiting other stars, but what we can do is watch the response of the star due to the gravitational pull by the planet. And we watch to see the star wobble in space due to the presence of the planet.
Like a hammer thrower pulled out by the weight of the hammer, he wobbles as he spins.
This is the most beautiful velocity curve in the history of astronomy. It really is.
Look at the postfix.
Jeff Marcy and Paul Butler are looking at a star. If it's moving in a circle, then its velocity will continually change in a repeating sequence, like a sine wave.
And this last point we just got last night, that is so beautiful.
That's beautiful.
And the points all sit right on a sine wave, showing that the star wobbles in a perfectly sinusoidal pattern, meaning the star is going in a circle, and hence the planet is going in a circle. So
this point here is almost like the first night we ever took data.
And we've been following this star for 10 years. This may well be the first bona fide solar system-like planet ever found. It's basically like Jupiter.
Searching for planets like those in our solar system is the frontier of current research. There's so much to be discovered. Maybe it will turn out that our solar system is not unique. But even if it isn't, the parade of planets that circles our sun is still an exotic group. And it seems to fall into a very neat pattern.
The solar system has kind of an organization. Close in toward the sun are the terrestrial planets, the planets that are made of rocks and silicates, like the Earth. Further away are the gas giants, mostly made of hydrogen, a lot of water, helium, contain a lot of gas and a lot of material. And furthest away are the icy dwarfs, things like Pluto,